Okay, welcome back. Hope the food is good. I mean, the food quality is pretty nice. I mean, in Pilani, I didn't have a mess with how good the food. And I heard that there's a few Bitsians in the crowd as well. A quick raise of hands who are from Bits. There were more people, they didn't turn up. Cool. So yeah, I think like they might come back. Yeah. Cool. It's always amazing. Like great to see people from your college. So yeah, we've had a look at some of these problems. I won't be taking any question, but like any comments on anything going good, not good, anything we should discuss in the coming going good? I should take what? I should take one more the extra for, oh yeah, of course. Yes. Yeah, maybe I should start my own YouTube channel and like how do you hey hit subscribe on that button and all. I think this presentation is on YouTube live as well. Yeah. And there's this big banner everybody's looking at. Cool. Okay, so hopefully we can sustain the energy going forward as well. We've talked about like recommendations generally. Actually, I mean, what percentage of this was new to you? Like 0, 10, 20, 40, 80? Okay. So what we've done so far is we've looked at a general motivation, right? I mean, that we want, somebody taking a picture. I want to make sure that there's a nice slide, which I have. I don't know if there is a math heavy slide. No, not this, not this. Give me a second. Might take a while. This is good, yeah? So look, I'm teaching you some cool deep learning stuff, right? We should all look serious in the photograph. Anyway, sorry, I'll come back. So yeah, I mean, we've talked about, like, generally, we've talked about recommendations and what sort of ML approaches exist. And hopefully, like, you've looked at candidate generators. And I mean, candidate generators give you a bunch of subset of candidates to work with, and the ranker gives you the final ranking. For ranker, we looked at multitask learning. We have looked at that multi-class learning doesn't solve that problem of exploration exploitation. So how do we do that? And then we looked at like multi-objective machine learning, right? I mean that, hey, the bandit can be, you can swap out the single objective, put in a multi-objective function, and that gives results. So this is all great, right? And now we can all go home and develop a recommendation system and earn money, retire. But there's a lot of missing pieces to it, right? We've covered the main meat of the content. If you're a vegetarian, we've covered the main veggies of the content. What we want to do next is talk about what else, right? What's going on? So here we want to talk about learning from user interactions. That, oh, I have a system, right? Which is working, which is in production, impacting 400 million plus users on a daily basis. How do we improve that system? So what we're going to talk next is this next topic. Yeah, so we're going to start talking about how do we learn user representations themselves, and how do we start learning generally about users, right? So we're going to focus on user representation for the next 15 minutes and then jump on to learning about users. So I think like traditionally, if you look at like user interactions, right? I mean, if you want to look at user representations, then there's a bunch of approaches which you can use to learn representations. And again, this is traditional stuff. And I mean, I'll pay my due respect to the traditional stuff, but then like move on to the recent advances. If you look at like, when we construct user models, right? So what's the goal? I need to have a representation of the user, right? I need to represent you. I mean, for you, it would be like, hey, in general, this person likes music from this content, from this genres and this topics. Or if you're on Amazon, then you kind of purchase on this products categories. Or what's your price sensitivity on Amazon, right? I mean, maybe you buy costly, cheap items and all that. So we want to construct a user embedding which can give me all of that. The question then becomes, what's the source of that content, right? The source of that content could be queries, content of web pages, product metadata, category purchases, so on. There could be explicit data that we ask explicitly, did you like it, did you not like it? Implicit data, product reviews, we can look at some context and all, right? So again, very self-explanatory, not going to spend time. But what you end up doing next is that you can start looking at timeframes, right? It's a short-term profile, long-term view of users. And in short term, you have certain interests, one-time purchases. In long term, you have some persistent user activity and so on. So again, you can get this data on multiple time frames and construct embeddings. And the question then becomes like who you're going to do this for, right? You can do this for individuals, you can do this for group. At least somebody in the room was very interested in groups. Yeah, I mean, you can do that for cohorts as well. Now, what do you do, right? With this source of data, with this timeline, what do you do? The simplest thing to do is simple TF-IDF, right? I mean, bag of birds, TF-IDF. Again, the respect I'm giving it is just like a mention. There's not even a slide on this because hopefully by now you know that I can just construct, look at the vocabulary, do a TF-IDF, word to vec on top of it. What I can then do is I can look at topical profiles, right? And I talked about LDA earlier. So this is exactly what goes on in LDA. It says that, hey, I am going to have a latent variable model. I only observe the word, which is the colored circle in between. Everything else is unobserved. And we can start saying that, hey, each topic is a distribution of words. Each document is a mixture of topics. Each word is drawn from one of the topics. Again, the details are not needed. Essentially, you have an LDA model that will give you a topic. And you can then look at what reviews the user has written, maybe in the review text, or what products they've bought, run it through the LDA. It will give you a distribution over topics. So this will give you like this, something like on the bottom right, right? You have a user, I have these 4 topics, and I know that user 1 is interested in these 2, user 2 is interested in the other 2. That topical embedding is something I can use for personalization, for ranking, recommendation later on. Now, interestingly, right, I mean, people have done this and applied it to other content as well, right? They have applied it to fashion. So if I can do LDA on top of, if you can do LDA on top of text, I can do that for images as well. So I can get these topics, and maybe some of these topics are more about like fashion, accessories, some jewelry design or something. And once I have it, then I can represent, even in the fashion e-commerce world, right? I can represent users in some of these like semantic topics. So maybe some person is more interested in necklace jewelry, some person is more interested in like bangle jewelry. I don't know what the topics for that look like, right? I mean, some clothing and all, right? So essentially, like the point is that you can use topics, right? And you can kind of construct user profiles on these topics. One of the things which I think people cleverly do is they look at Wikipedia as well. So if you look at Wikipedia, right, the Wikipedia has some of these categories, and you can look at that category as the space on which you can have a vector, right? If there are like 20 or 200 categories in Wikipedia, then you can have a user embedding on top of those 200. So each user has a value between 0 to 1 for each of these topics, right? Again, nothing fancy there. The other stuff which we've seen so far is like, hey, I mean, I have a tensor, I can have a matrix factorization that will give me a latent factor. That's the user representation. I can do a tensor decomposition. I can do neural collaborative filtering, all of which we have seen before. So nothing new here. The neural embeddings is something we have looked at as well. Like, I mean, again, these slides are outdated. You have the word-to-vec embeddings. Now, what people have done is they've said that, hey, in Rex's, right, recommendations community, they have said that I can, instead of just using word-to-vec, I can use word-to-vec with some additional side information. And the side information there is that there's a disconnect between this and this. Sorry. Oh, yeah, okay, here. Yeah, so basically, like, instead of just embedding users, I can embed the product with the metadata together and learn some of these embeddings, right? So again, the moment you have these neural building blocks, you can start playing around with this easily. And then people said, hey, I mean, let's do something else, right? I mean, we saw this before. We saw this neural collaborative filtering diagram. Here, people are saying that we should do a joint model wherein I look at the user, I look at the item, and then embed them together. So here you start seeing that, I don't know if the pointer works. Oh, it does work. I haven't been using it. Cool. So you have the user review text, you have the item review text, you can pass it along and then train it together, right? And then any of these last layer can be an embedding itself. So again, like similar architectures which we have seen before. The question then becomes that when we start looking at short-term, long-term, right? So there is, at least in the search, there's a nice paper at Sigayar, this is 10 years ago, that I can look at the aggregate view of users, which is a long-term history, right? Going back to 1 year, 6 months, 10 years for Spotify. And this could be the historic, and then I can do a local session-aware embedding or session-aware representation. Now, in general, you might be interested in some topics, but then your local session preferences should overrule the global preference I have for you. So I think like this is a nice, very like non-technical introduction to what happens, right? 2 years ago or 3 years ago is when Google actually launched session personalization in the Google search results. So if you see right now, right, by the time you type in the third search query, it will be impacted by what you did in the first two queries. So that session level personalization is looking at the session level history. It might overrule and overshadow the entire history, right? So again, like the model is deciding real time on what to pay attention to, what to focus on. So again, this is 10 years old. We can start doing this exactly with the short-term attention model. I'm going to spend 5 minutes talking about this because at least we have taken a picture with this image. So we should at least spend some time. But I'm going to talk through this architecture and say what's happening. But high level, right? You start seeing this, right? That there is a green content, which is the local session. There is a blue content, which is historic. Now, given at this point of time, I need to make a decision on should I pay more attention to the blue box, look at the historic preferences of user, or should I pay more attention to the current session, right? And then make a choice because maybe they're all similar or maybe they're not similar. And the history says that the apple you are looking for is the apple fruit, but the apple you're looking for in the session might be the Apple company. So how do I make that decision? So this is what a 2012 version looks like. And this is what a new 2020 version would look like. Cool. So there's a paper at KDD 2018, which talks about short-term attention model. So how do we capture correlation between users' long-term and short-term history? So what we do is like this is what we're gonna work towards, right? So we're gonna have a session, we're gonna have a bunch of candidate items, and then we will try to look at the user history, the candidates, and then do some decisioning, right? Let's break it up. So again, candidate generator gives me a bunch of candidates. So I have this candidate set to look at. Now the question is, I want to decide whether this XI is useful for me or not. Cool, I'm gonna look at the session. So I know that, hey, the user has this history, right? I mean, maybe 10 hours ago, they were interacting with X1. Just last minute, they were interacting with XT, right? So there is a user history over here. What I can do is I can pass them through an attention mechanism. So in the current modern world neural architecture, right, you would have seen transformers. I think in the NLP class, you would have raised of hands, who knows transformers at least. Cool. Attention mechanism, slightly. Attention mechanism. Have you heard about attention mechanisms at all? Cool. I mean, at least a few. Okay. So I mean, yeah. So I mean, without going into detail, but the attention mechanism gives you a way to identify what to focus on from the prior history, right? So this is exactly what could go on here, right? You can have the history, you can have the current item, and then you can pass it through the attention mechanism that gives you the session level representation here, MS, right? And then you can pass it through some full stack layer. And now here, right, this is where you're doing a trilinear combination. You're saying that, hey, I have the session view, I have the most recent view, and I have the candidates. And let me incorporate all of that into making a final decision that whether should I show this content or not. Taking a step back, what's happening? What's happening here versus what's happening here? Ideologically, very similar. I'm looking at the recent history, I'm looking at some long-term history, and then making a decision on what to focus on. Here, I would have done maybe a weighted sum, a very typical naive version. Here, we have an attention mechanism to pay more attention, right? So this is the title of the paper, right? I mean, short-term attention, memory prioritization. Like, what do you want to focus on? We are having this attention layer guide us there. So that's what's happening. So this is what an in-session personalization might look like. Yeah. Yes. Right. Yes. Right. Yes. Great point. Yes. So I think this is decisioning on a user level. But then if I don't have any relevant user history to look back to, then I'll go back to my defaults. Right. Defaults are the priors you have in a Bayesian model. Right. You have your prior distribution. So the prior will allude more to that. Hey, Apple in general means the company, not the group. So yeah, I mean, what's the point here, right? The point is that, look, we are representing users. We have looked at some very naive way of representing users. And then once I have that, I can look at a long-term, short-term view, have an attention model, develop these for me. And I think something very simple, I've mentioned that a few times. You can have the individual, but individually when new users come in, new content comes in, I don't have that content. So maybe I can look at a global is not personalized. Maybe I can do something in between, which is cohort and group level, right? So again, this is also like 8-year-old paper from Microsoft Research talking about how do you do cohort modeling for web search. So again, like English intuitive line, nothing new here, right? We have talked about this before. The interesting part comes in when we have multiple views of data. And I think there's a very nice Spotify paper coming up in a few slides. But essentially, right, what we generally have is I have multiple views of the user, right? I have the kind of the text of the messages they've been posting, the neighborhood in the local network, the articles they link to, the images they upload. So there's like multi-dimensional view of the users available. So instead of learning just from one modality, right, I can learn from multiple views of the user. And that should give me a richer user representation, right? I mean, if I have more data, why not use it, essentially? So then essentially this multi-view model learns a single vector from each of the single views. Now this is where, right, I mean, you start then deciding that, oh, which view should I pay more attention to, right? So then like there is a differential weighing of each of these views, and then there is a way of identifying which view do you give more importance to. But the key point over here is that the embeddings, right, they are learned from multiple views together at the same time. So again, neural network model, again, this is optimization, right? I mean, the community evolved, they said, oh, I can do that in a neural network. So then there was a nice developed paper in 2015 on very similar to a two-tower model, essentially, which we have looked at. But then like you have view 1, view 2, view 3, and then they all kind of give you corresponding embeddings. The one good thing which actually like helped us a lot at Spotify was this multi-view, right? I think somebody was talking about domain adaptation as well. Sorry, what's your name? Muskan. Yeah, so Muskan was talking about domain adaptation as well. So one of the things which we like at Spotify like benefited a lot was that as a platform, we wanted to surface more podcast recommendations. Now, as a user, how many of you stream podcasts on Spotify at all? Very few. I mean, how many of you actually use Spotify? Oh, I was scared that like, am I in an audience which doesn't? Yeah. I'm scared to ask, how many of you actually use Moj or ShareChat? She said it was nice. Okay. Good try, nice. Cool. I'm not going to hold that against you. My speech quality is going to reduce by 20% given this answer. But yeah, essentially, right? I mean, like if you haven't been using podcasts on the platform, then I don't know anything about podcasts, right? You're a cold start podcast user to me. So how do I recommend? How do I personalize there? One thing which like Zara, she was a lead scientist on this, right? I mean, she had this great insight that, hey, we have a lot of music information. Can I use that music information to personalize podcast? And this is exactly what we ended up doing, right? We said that, hey, I'm gonna have an architecture which gives me a bunch of user embeddings, which I'm mapping from music to podcast. And that actually worked tremendously well, to the extent that it gave us like pretty company-wide metric wins here. So we were able to show that, hey, for this podcast, there are specific genres of music which are greatly predictive of user engagement on some of these top podcasts as well. So I think what's the point here, right? The point is multiple views of data, even across domains, is helpful. One of the internships I did at Bing 2015 was how do we look at news consumption for search personalization and vice versa, right? I mean, if you go to search engines, you can go on the news tab, you can consume something, and then on search. So how do we look at domain? I think people at Spotify, this was actually deployed in 2019, 2020, and it gave like pretty amazing podcast engagement metric wins for us. So again, same point, right? Multiple views of the user, they can be helpful. And finally, taking a step back, like multitask learning we have talked about in the past, that I can make multiple predictions about users, probability of liking content, sharing content, commenting on content. All of that will give me some representations which I can start using. Right. 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 Yeah. Yes. In the music to podcast, suddenly the question changed dimensions. I was prepared to answer that in the general setting, but now you're saying that how do we do that in music to podcast? Right. Okay, of course. Yeah. Good. The question value suddenly was high and then it get down and then brought back up. I'm going to answer the first question which I thought you asked, right? Which is that what are we training this on? I'll come back to the podcast question in a bit, but I think you brought a nice point, which is that hey, I can train all these models, right? But then what am I training it on? Like maybe the labels and the engagement signals I have, right? They're biased. I mean, look, you're training it on historic data. Where is the historic data coming in from? That historic data is what your model decided to show to the user. So there's a feedback loop here, which is bad, right? Because hey, I mean, I'm training for a model. The training data is coming in from what the model decided to show last week. That's what your history data is. So then there's a bad feedback loop here, that you are only training on the data which your model generated. Had the model decided to show some other recommendations, you would have gotten that data in your training set. But because the model decided to show this, that's the only data I have, that's the only label I have, and that's bad. This is where, right, I mean, the randomization, the exploration, and making sure that there is enough random exploration going on, that at least makes the training data a bit heterogeneous. So we're not just training on the ranker data itself, but then we're training on some other data. So that's the first question, which you never asked, which I thought you did ask. The second question is for the podcast, right? I mean, the podcast there, right? I think like it's kind of an ensemble approach that we are not just gonna rely on the music, right? I mean, hopefully, I mean, I'm not 100% sure what they ended up actually developing it because I was paying high level attention, not enough. But I think like on the homepage, right? I mean, on the homepage, the entire, I mean, remember the bandit model, right? So this podcast is a shelf on the bandit model. So then like, how do you score within a shelf? That could be based on these multi-view embeddings. That could be also based on what's the popularity of the show itself. Some shows are popular recently. So I think like there's a bunch of ensembles which go in over there. If not, then I think the right approach would be to induce some randomization there as well, so that you're just not putting all your eggs in one basket. But this was easy, right? I mean, like I've not talked about, I mean, literally taking a step back, none of this should be new to you. If it is, then I don't think you've been paying attention. Essentially, we want to learn representations. There's a bunch of very, very obvious ways of learning it. There's a bunch of very nice neural ways of learning it, and maybe multitask ways of learning it. The goal is I can train a neural network model and get an embedding. I can get an embedding from word to vec as well, or I can get an embedding using some fancy architectures. So that's a list of how people can learn representations. The next part is slightly more interesting, slightly more non-obvious, but intuitive. So this user representation will give me a user vector and I can use it everywhere, right? I can use it in my CG candidate generator. I can use it in my ranking step. I mean, if you look at the two-tower architecture, right? If you go back many slides ago, if you look at this, right? Now, if you have a way of representing users, you can then come back and like start augmenting it here. Right? Let's say you have this already deployed, but now you come back with, oh, I actually have a topical embedding of user as well. So then nobody's stopping you from just adding another concatenation layer here. And now suddenly your two-tower model is much better. Tomorrow you have an intern who comes in, oh, great, I attended this amazing summer school wherein some guy was really talking about cool stuff. And now I have a new way of learning representations. I'm like, cool, you have it. Let's kind of implement it, add it over here, right? So these models are very, very addictive. Same for the graph stuff we were talking about. If you have a good graph embedding, then you can augment it with a bunch of these. The node features can be extrapolated with some of this content. So that's how you can start using these representations in anywhere in your stack. But the interesting part comes out in some of these other tasks here, which we're going to start getting into in a bit. Yeah. So when we start learning about users, right, then there's a lot of other prediction tasks which we should be making. So we had a paper which was an amazing academic collaboration. So Ashton is a professor at Toronto, and he was kind of doing a part-time 1 day a week thing with us at Spotify. Disclaimer, I interned at Microsoft Research. He was a postdoc there. So he's a great computational social scientist, comma machine learning person. So doing some amazing work at Toronto right now. So we were looking at the diversity of consumption on the platform. Now, this is what we found. We found that there are a class of users who are specialists and a class of users who are generalist. So specialists have a lot narrow consumption horizon. So they care about one genre and one type of music, and that's it. They don't do anything else. But then the generalists care about a lot diverse content, right? So the more, I mean, the intuition is the more the spread out your behavior is, the more generalist you are. I mean, how many of you here are more generalists in your music consumption? But within a, right? Yeah, so suddenly you kind of made this a bit more hierarchical, right? That instead of generalists, I mean, I could have things, and within each I could have this. So it makes sense. How many of you are actually like a specialist over here? And is it different on music? Like your music preferences, your generalist or specialist, or consistent? Cool. I'm sure like Spotify will have a hard time modeling you. But essentially, I mean, I've observed that like on movies, I'm like a very, very specialist person. Like, I mean, there are times in which I'm just looking at like those Karate Kid style movies, right? All the Asian movies, all of that. And then there are times when I'm doing something really different. But on Spotify, I'm more of a generalist. I mean, we did observe that user perception of them being journalist specialists and their actual reality is very different. So again, like that's also the case. But again, like let me come back and make it real, right? So again, like once you have these embeddings, right, you can start doing some calculations of like how generalists and specialist users is based on the cosine similarities and all, like very simple functions. But what we did was, I mean, it's very important. I mean, again, this is a nice data insight, data point, that when you plot the generalist specialist thing, don't just say that, hey, the users are spread across. The follow-up question I'll ask is, have you controlled for activity? Right? I do expect that, like, if you just listen to 10 tracks, maybe you're a generalist. Right? If you listen to 1,000 tracks, maybe you're a specialist. Right? So this is a nice part. Like, is it confounded? We're not, I mean, this is not relevant to recommendations in general and specifically, but a lot of the times a good data scientist will ask you this question: is the analysis you're presenting, is it confounded by other factors? So I might tell you that, hey, in general, you know what, these users are more specialist. But then the question is, are they more specialist indeed? Or is just that like the other journalists, they've only listened to like 5 tracks. And then you think like, because they've only listened to 5 tracks, then they are generalists. Or they're specialists versus somebody who's listened to 1,000 tracks, they're specialist. So again, when you're doing the data analysis, make sure that you control for a few of these things, right? The way we control for this here is by controlling for activity levels. So if you zoom in, right, if you look at this, so then I'm controlling for activity percentiles. I plot all the user on the activity range. So users who are like very less active on the platform are here. Users who are very active, streaming a lot, are here. But the trend is that for the generalist specialist score, like on the right, I have specialists, less diverse. There's a common trend over here. Importantly, across colors, the trend is very similar. So that means the generalist specialist is not confounded by the activity percentiles. Even controlling for activity percentile gives me this nice trend. This is not needed in recommendations, but then I think like as a nice, good-looking data scientist, data analyst, you should be controlling for a few of these things. If you give me a presentation wherein you have a general score without controlling for it, I'm gonna slightly judge you that, hey, you're not really that sharp. But then what actually, okay, why does it matter? The best part which we came back with was that journalists and specialists exhibit different retention and conversion behavior on the platform. So on the x-axis, we have the GS score. On the y-axis, we have probability of churn, like how many users churn. Churn means like they quit paying the subscription fee and then they kind of churn from the platform. Now, the more a specialist somebody is, right, the higher the probability of them churning. Now, this is a great insight. This kind of combines a lot of things you've been discussing since the morning. This is why I want users to become more generalist, because the more specialists they are, the higher the chance of churning from my platform. Churning is like abandoning my platform, going to Apple Music or whatever. The interesting part over here, I don't think I have it here, which is if you look at users' organic consumption and our programming, then you see a difference. And let me explain what's happening. If you go to your library, right, your library is under your control. I can't influence it. So that's what you really want. So if I look at your library consumption on Spotify, that's very diverse. So you are kind of a generalist there. But on the home page, you are a specialist. And that means we suck, right? I mean, that means like, hey, we are forcing you to become generalist, which is not healthy for my platform. So again, this is the analysis, which again, I don't think this is a great MLE project, but this is a nice data scientist project. That, hey, find out where the money is at, where on the platform level, what mistakes are we making? And then this should guide the decision. You know what, diversity should be a nice element here. So we should take on the feed ranking. The feed ranking was single objective. Now we have seen good evidence controlling for a lot of these, that we should enforce diversity on the feed because the feed is not as diverse, right? So again, it's a nice example of doing some nice, clever data analysis, but then with the right sanity checks and then making a claim, making a point. So again, taking a step back even further, right? Why do I care? I've been a marketplace, right? I mean, if you look at me, you should look at like that one figure which had the stakeholders, user, artist, platform, right? Now, who among these users would I love more? Generalists, okay? Any other answers? Why? Right. Yes, exactly. Right. So I think like generalists are the users who I will love more. Why? Because they anyway have a wider horizon. So if I have to expose this tail creator, tail artist, I would do that to a generalist, right? And not do that to a specialist. Why? Because I think that this user is usually like more open to some of these recommendations. So what's the point? We were looking at multi-objective models, right? Up until now. Now, suddenly, if you are making that prediction or an estimation about the user, you can use that in your multi-objective decision. Right? So suddenly I'm walking towards a world wherein it's not just an ML model. There's a bunch of satellite ML models, a bunch of other predictions I'm making, and I'm going to start using those predictions in my decision-making process. Let me give you another example. Something which we did at Rex's 2020, user receptivity. Now, one of the insights I had was that, look, I've been a Spotify user for 12 years. No matter how shitty recommendations I get, I'm not going to go away. Like, what's the worst they could say? I mean, recommend me some crap music. It's fine. I love the product anyway. Not because I'm an employee, but like I've been a paying customer since my Bitcoin days. So some users are very tolerant, right? I mean, they're not going to go away. Some users might be on the brinks of leaving to Apple Music, Amazon Music, whatever, right? Now, again, same question. If I have to show a tail creator, who do I show it to? A tolerant user or a non-tolerant user? Right? I mean, again, very obvious, right? That make a prediction that is the user tolerant, is the user not tolerant, and then use that to inform your decision. Again, what am I doing? I was predicting diversity consumption. I was predicting user tolerance. I will make it my job to make any of these prediction models and just make it available so that my multi-objective decision-making system can do a better job. So this is where you start seeing that, look, machine learning in the industry is not just machine learning to make a prediction which solves your problem. It is to make a prediction which can influence other decisioning as well. So here you have an ML model. The output of it becomes an input in another ML model's predictions, right? Decisions. And I think, how do you do this, right? I mean, how do you understand like whether the user is tolerant or not? So then we said that, okay, let's see how receptive are users. Can we define receptivity? Can we predict that? Is it predictive of future engagement? We did all of that. We looked at different forms of receptivity, like engagement-centric, effort-centric. I mean, intuitively, right? If I start showing random content to you, maybe your engagement drops, that's it. Or maybe you put in some effort. Oh, I don't like the content, but I will scroll, I will search, I'll go to the artist and find out what I want. So that's like effort centric. The other one is stickiness. I annoyed you. Did you abandon us forever? Or did you come back in like 2 days? Or for some users, it took a week for them to get back. So there is a distrust, right? When I do some random things to you, hey, what crap is this? I don't like it. But then like some users, they forget about it, right? They're more forgiving. Some users, the stickiness is more. So we wanted to understand those nuances, made these predictions, looked at a bunch of features. Again, a lot of like non-ML, but a lot of like nice data analysis work here. We had these user attributes like audacity. How much skipping do users generally do? Currency. How regularly do they listen to brand new music? Nostalgia. To what extent users listen to nostalgic content? There's a long list of some of these features, right? The question then becomes like, if you're a good data analyst, good data scientist, I don't care if you're a good ML engineer or not, but then a good data person would think about these features, look at ways of quantifying it. Some of these could be an output of another ML model itself. Some of these could be easy to calculate. So then I'll have a bunch of these and then get these features, train a model, right? So again, to train the model, what we did was we did some random distortions on the homepage. to understand, right? I mean, how okay you are if I randomly start distorting, and we use that data to develop a prediction model. I mean, long story short, we were able to, I mean, I'm skipping slides because it's very obvious now. I mean, it is to me, hopefully to you as well, that we were able to kind of predict receptivity, tolerance, and engagement. Receptivity was far more predictive than effort and stickiness. But the important thing is here, which is this receptivity is predictive of future engagement on my platform. And this is important. Why? Because if I want to use this to make my marketplace decisions, right? Now I have a signal here that, hey, you should respect this tolerance score, because if not, then future user engagement is impacted. If I'm starting to show some tail creators, some revenue product or anything, right? And if I start showing it to non-tolerant users, their future engagement will drop. And that's a bad decision which I'm going to make. So this is where a bunch of very nice trade-offs happen. Before going into it, I'm going to talk about this. I mean, this is fine, right? I mean, like, hopefully this is okay with everyone, that we can predict tolerance and use that. Now, let's take a step back. Let's remember that so far you've been talking about marketplace, right? Now, in a world of trade-off, I have to keep the user happy. I have to earn enough revenue. I have to keep my creators happy, right? Oftentimes, I will be faced with very hard questions and decisions. One of the scenarios is, hey, you know what? My ad revenue is really down. My creator objectives are really hurting. So I know this is not the right thing to do for you, but I'm sorry, I'll have to push it. Why? Because I know you won't like it, but then I got to get my creator objectives high, right? I got to earn enough money. I got to make sure that all of the other stakeholders are happy as well. So this is when the system might intentionally go against your wishes, right? I mean, look, it's not a bad thing to do. Why? As long as it's controlled, right? Even if you had not done this tolerance prediction, you would have anyway done it, right? You just start like, you're just closing your eyes and hoping that I don't know the user's tolerance, so maybe it's fine. But right now, all I'm giving you is more control. That you make the prediction, you understand where is the edge for the user, and try to remain within that boundary, right? At some points, you will be faced with this difficult decision of crossing that boundary, and you are willingly doing that because that's the trade-off you want for your platform. And you cannot shy away from that, right? Because you as a product owner owns a platform, you know what you want to do, earn more revenue at the cost of user satisfaction. Maybe that's what you want to do, you do it, right? Yeah, yeah. Right. Yes, yes. I mean, yeah, exactly. So that, I mean, that's what, right? I mean, now at least the goal for these two, right? I mean, these two are examples wherein we are learning about the user. Now, what do you do with it? It's up to you, right? One direction, somebody could say that, oh, you know what? I should make it more diverse. You're saying that I don't care about diversity. Let's just reinforce that behavior, right? If there's a specialist, let's make sure that we give them special content so that they remain a specialist, they remain happy, right? So again, that's you deciding as a platform owner, this is what I want to do with that information, right? So there is an important point here, which is that I think some of the ML engineers should develop these models and not care about how somebody uses them, because it's beneficial for the system to have it. And then the product owners can consume this and design a policy. Your recommendation policy is very different than my recommendation policy. You're saying that, hey, I'm going to reinforce that. I mean, if I know this is a specialist, I'm going to double down on it and give them that content and just keep them happy. I'm saying that, oh, you know what, like, no, that's not good. Long term, I need them to become generalist. So I want to start showing it, start making them more generalist if I can, right? So again, different people can use these outcomes differently and at different needs, right? Maybe like at some point, I really need to get my other objective stakeholders high. So then I'm sorry, I know you are not tolerant. I know there's a chance you might go away, but then I really have to earn my other rewards. Yeah, yes, yes, yes. I mean, we do. I mean, the current production model working on top of the OWL functions we're talking about at Spotify, at least the one we deployed, my team, and hopefully it's still there. is looking at the sequence, right? We don't, again, like we are okay with like you getting annoyed a bit, right? But then like, I mean, look, that annoyance is also like subjective, right? I mean, you expose that enough, you might develop a taste, right? So there's a depth in the user preference as well. Like, I mean, you don't like it, it's like wine. I mean, again, hopefully you have or haven't tasted wine. I have or haven't tasted wine, whatever that means. But essentially, like people develop a taste for something, right? Maybe they hate it at first and then they start enjoying it, right? So who knows? Like some of these long-term predictions might turn out well. But the point remains the same, that I can make these predictions and start using them for policy making. Let's look at intents, right? Something, I mean, it's very different than what we have been looking at. But intent is such an important problem for everybody, because in search, you have the search query that tells us what you want. Here, I don't have the search query. So we had a paper at the web conference, WWW in 2019, talking about this. I'm gonna, let me, before going into detail. So I have a user, and the user has been skimming a few tracks, right? They come to the platform, I show them some content, and they skip like 4 or 5 tracks, right? Now, is that a good thing? Is that a bad thing? I mean, generally the idea is, hey, they're skipping a lot. That means it's not a good thing, right? But then you know what? Like they have been just me sampling songs. Like I have a party at my home in the guest house tonight, right? Why not? Professor Anban is gonna pay the bill for that. You're all welcome. So I have a party tonight, right, in the guest house. And again, I want to create a good playlist for that. So I'm not going to complete tracks. I'm going to sample a few tracks, listen to them for like 5-10 seconds. Oh, this is nice. I'm going to add to the playlist and then move on. That to me is a very satisfying session, right? Just because I'm skipping all the songs doesn't mean I'm not happy. What's the difference here? The difference is the intent. If the intent is to create like save music for later, then the signals mean very different. If the intent is to have a very successful session right now, then the signals mean very different, right? So the point we are trying to make is, look, when you try to predict satisfaction, then you should condition on the intent. The interpretation of the interaction signal should be conditioned on the intent. I'm going to repeat that again. It's very English, but just ideas, not core ML. But the interpretation of the interaction signals like skips and all, how you interpret that should be conditioned on what your intent is. So then there's a very strong need for me to identify intents. Now, how do I know the intents? You come to the platform, you literally just, I mean, I'm just open like Swiggy right now, right? There's no way how it can find out I've had dal and all that. Right now, I'm in the mood for Thai cuisine, right? How the hell will it know that? So again, I'm not giving it that query. So how do we understand intent? The question is, what does the space of intent look like? So this is what we did, right? We conducted some in-person interviews. We kind of ask a bunch of questions around what your goal expectations are and all that. We did some, I mean, we did a lot of work. I mean, in the details in the paper, it's very non-trivial to the extent that Netflix exactly is replicating this. I mean, at least as of 2021, they were replicating exactly that. So, I mean, Spotify and Netflix people were talking, which is also something which is very, very common. Like Shivam, I think he's going to come in next week from Swiggy. They're working on bandit models. Me and his team, Jairaj, he's a VP at Swiggy. His team and I have been talking for like 2 years now. Netflix and Spotify have been talking on this intent modeling for a long time now. So I think, I mean, you see a lot of industrial people. I mean, it's like a therapy group, right? That everybody is kind of craving out, oh, it doesn't work. How do you make it work? Oh man, I don't know how to make it work. So I think like we all kind of cry together. But that's fairly common in the industry as well. So again, my point being that, look, I don't know what the intent space looks like. I need to find it out. We did some user research, did some work, details in the paper, but then we identified that, hey, there is a bunch of intents right here. One is some people want to quickly access music, or some play in the music in the background, discover new music, or explore artists or playlists for later and all that. So I mean, your intent will also rely on, I mean, that's a good point. I mean, your intent will rely on your expectations from the platform as well, right? Yeah, I mean, that's why it's a hard problem. I mean, it is a very hard problem. I mean, I'm not denying it's one of the hardest problems, right? Because, I mean, look, TikTok does this amazingly well. Within a session, I mean, they were able to scarily identify what is it that I want, right? So they have that metadata content understanding as well. It's not just about the user, it's about, do you understand your content enough to find out that pattern, that this is the specific thing the user is looking into in the last few minutes, right? So I think that in-session personalization needs intent understanding. That intent understanding needs metadata understanding. This is why ByteDance has an army of labelers labeling that content. You won't believe how much money my team spends on getting this label data. Like it is in the tens of lakhs per month on just getting that label data. Label of like show it to the users, show it to domain experts and tag it. What is this video about, right? What's going on in this video? If I don't know what this video is about, then I can't understand what you're doing, right? So again, intent identification is important. These were some of the intents. The question then becomes the final model which I want to pitch. What do you do with this intent? Now you can have a global model, right, which says that, hey, I don't care about intents. I'm going to predict user satisfaction agnostic of the intent. So you have the same set of parameters across all the intents and you develop a global model, right? It's going to give you some satisfaction prediction. You can then do is, no, you know what? I have the intent. I can predict the intent. But once I have the intent prediction, I'm going to use that parameter to decide whether the user was happy or not. So this is a per intent model, right? I have, let's say 10 intents. For each intent, I have a separate model. What model is it? The model is to predict satisfaction, right? I mean, the first line of this is, I want to predict satisfaction, whether the user was happy or not. And then I can ignore the intent, have a global model, or I can have per intent model. But there's a problem here. Global intent is losing money on the table. It's like not leveraging intent information. The per intent model is just looking at per intent, right? It's not doing any transfer learning across. So then you can do something like multi-level models. So this again is a very common statistical approach, which if you are into Bayesian statistics, then you know what multi-level models are. And if not, then I'm not the right person to talk about that because this is not as relevant to recommendations. But the key high-level idea over here is that one, the internet connection is unstable. Two, that I have global parameters, but then I have a per intent parameter as well. And then I can use both of these to make a decision, right? So I'm not just, I mean, both of the other extremes are bad, right? Because in the global model, you're just looking at global. In the local model, you're not doing any transfer learning across intents. And now you can do a mix of both. And like, I think this is a very, very heavily libraryized area. By that, I mean, there's a lot of tools, a lot of libraries which do multi-level models for you. And that gave us some good improvement in SAT prediction problems. Cool. What's going on? I mean, I was talking about predicting about users in general, and I think this is something like Pinterest does in a very good way. So there's a paper at, I think, WWW 2017 or something. I mentioned this like graph-based GNNs, right? Uriel Leskovic, he's a researcher who was a chief scientist at Pinterest until earlier this year. Amazing research on GNNs. But yeah, so they said that, hey, I want to understand intent on Pinterest. And one of the things which they liked was that they looked into how quickly can I predict intent. The moment I know your intent, I can make recommendations based on that. But this is what it looked like. The intent prediction accuracy after a while was pretty stable, right? So again, I don't have to wait for 45 minutes, 30 minutes. By the 10-minute mark, I know what your intent is. So I don't have to wait longer. Interestingly, right? I mean, even at a 30-second timeline, I have a pretty decent accuracy. So the moment you start interacting, right? I mean, I'm still at 0.65. I go to 0.75, yes. But at least like, I don't have to wait longer. I mean, at 30 seconds is good enough. Importantly, at 0 seconds, it is non-random, right? So users have this reinforcing behavior that they want to come back, reconsume information, do a lot of this stuff in time and again. So then they can start consuming similar information. So I can do intent prediction even when you are like at time is equal to 0, right? And then I can do that later on as well. After a while, no additional information. But then even at like earlier in the session, I mean, this is useful. Yeah. I mean, we do, yeah. I think like the models are not cognizant of that feature yet, but then even like the loudness, right? I mean, look, I mean, I will play music, loud music when I really am very caffeinated. I want to like break the windows or whatever, right? But then like, I mean, we do, I don't know. I think we do have the loudness as a feature, but it's not getting used, at least to my knowledge. But we do know like what device you're logging into the Bluetooth, right? Because when you drive in the car, we put on the car mode, so we know what device you're connected to. Is it like a headphone or something like that? So That can be used. Yes. 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 That can be used to inform the intent design. Yes. Cool. Any questions so far? I know this is also post lunch, so that drowsiness is expected. So I'm going to discount some of that. Yes. No, I mean, true. I mean, true, not true, both. Because look, I mean, if I think I think I'm conflating two things here. Sorry. I think like one of the things is what do you do with this intent prediction? I think I'm talking about two separate papers here, which is why let me clarify this. The Spotify intent work was not time aware. It was just to identify the intent so that I can know the satisfaction. I think most likely this is for personalization. That predict the intent, not to evaluate, but to act. Right? The moment you know that this is the intent, then I can re-rank and recommend the next items based on the intent. Yes, perfect. So you're kind of auto completing me in saying that. Look, I mean, this is great, right? I mean, people are predicting. I'm so obvious now. My pitch, my entire narrative. I've done a great job at selling my story. That people are. What's your name? Sorry. Vibhuti. So Vibhuti is able to kind of predict what I'm going to say next. What do you do with this, right? You exploit that to make money. I mean, to keep the other stakeholders happy, right? So you have these intents, and as Vibhuti pointed out correctly, some intents are more amenable for me to show some other content, some intents are not, right? And then it's about you make that available, and then somebody smart enough who's gonna make some money out of it, they're gonna start consuming it and make a policy out of it, right? So this is a general theme, which I think is true for, I'm gonna come to in session in a bit, but I think like generally, right? I mean, what's my point amongst all of this? If you learn more about the users, you can do a better job in your job. Your job could be to make the user happy. Your job could be to make the creators happy. Your job could be to make more money for the platform. Your job could be anything, right? But developing prediction models, estimations, doing some clever data analysis, clever modeling, right? It's going to help you no matter what. And it's up to you to kind of, I mean, there's money on the table, right? If you're not stretching your hand and grabbing it, then like, I won't blame anybody else. You're the one to blame. But there's another point here, right? I mean, the ML over here is not just ML for recommendation. So to me, the most cleverest person in the team is not only the person who develops a new multitask learning model. It is a person which develops this new prediction model, right? Which I can use to make a better decision tomorrow, right? So there's a bunch of satellite ML models spread across. Every company will have many prediction models, right? And then some prediction models at the core of the ranking will start consuming it in different ways and all that. So I think like if you think that the ML industry, or I mean ML in the industry is just about, hey, one model, and if I'm developing the next best approximate SVD for this, that's it. I mean, every other job sucks. That's far from true, right? Because I mean, some of these models are already deployed. The next money on the table is via some of these, right? And this you cannot do if you're not looking at your data. That is the one biggest learning which I think you should all take away from. If you are an ML engineer, if you're not looking at the data, doing the data analysis, then like you're committing suicide on your ML career. And this, again, like I will put my name, put it on the record on YouTube or whatever, right? I mean, I've seen that happen time and again, time and again. What ends up happening is we have a bunch of data scientists, we have a bunch of ML engineers. The ML engineers are very pro math. Oh man, nice calculus, nice differentiable operators, like why not? Let's do that, right? They spend zero time in looking at the data, understanding the problem domain nuances, right? The idea Vibhuti you had, right? They will not pay attention to it. They won't, I mean, I'll rather say they won't give respect to it. Why? Because they have been trained to respect the heavy math in the papers, right? They value cool theorems over insights, which is great for them, right? In whatever career they want to have, great. In an applied industrial setting, I don't think that will go far enough. And I've seen it personally. I've benefited from it personally, selfishly. And I mean, I've hired a bunch of people, helped hire them at Spotify, hired them here. In my experience I've had, it is limited, right? I mean, not experience as somebody is sitting on the front row, but I can put my money on the table and say that, look, I mean, if you're pro math, great. I mean, we need that. But then if you're not looking at the data, not finding out the insights for yourself, if you're hoping that some data analyst will do the diving, and then you won't know where the model sucks, you won't come back with the next set of ideas, right? So I think that to me is one thing which, especially students, right? I didn't value evaluation. I mean, when I entered my PhD, I was like, I mean, literally the first few papers, you'll see a lot of Bayesian non-parametrics. Math is sprinkled on the work I do. I could do that without the Bayesian non-parametrics, but I was stupid. I was like, hey, I mean, I value, like, why not? Like, I mean, Bayesian non-parametrics do some nice math, heavy work. So I was very pro that. You spend time in the industry, you realize none of that works. I mean, it does work if you know how to make it work. It's very hard to make it work. So then the people who have good ICML-ish understanding, and they're good at these www, SIGIR, KDD style evaluations, right? I'll show you an example. I mean, this is totally off the record or whatever here. If you look at a bunch of these papers, any one of these papers, right? Look, this is what people in the ML community used to do. They used to develop a model, they used to show the topics, do some one table of evaluation and get published. If you look at this wisdom paper, right, it starts looking at, okay, there's a lot of data analysis here, that what's the trade-off, what's the track level correlation, what's the density and all that. But then later on, it starts looking at, okay, there's a model, but then it starts looking at the trade-off. Oh, what do we gain? What do we not gain? How do I make this go? Oh, you can't see it. I have a blocker here. How do I hide this? Cool. Yeah. So if you look at this, right, I mean, in this paper, we said that, okay, we want to do multi-objective modeling. Let me look at the trade-off. Let me look at how the satisfaction metric is correlated with discovery. Now, things on the top right are great because high satisfaction, high discovery, none of it exists, right? So this guy is great because it's giving me enough gain in satisfaction, enough gain in discovery, great. But then it's not enough. I want to look at, okay, you know what? How much is satisfaction for different amount of discoveries? So I looked at sessions which had zero discovery. I looked at sessions which had some discovery, which had a lot of discovery. What's going on there, right? I did that deep dive, not just enough. I looked at, okay, you know what, like, what's the trade-off in each of these? Cool. Then I looked at, okay, what's the discovery proportion in the set? As you go along in the set, how much are you discovering, right? And then that wasn't enough. I looked at users. There's a user level heterogeneity. Some users are kind of liking it a lot. Some users are not liking it a lot, right? Not just enough. I looked at supplier effect. That this ping guy shares that I am able to shift supplies towards the right. That means I'm able to expose tail retailers a lot. What's my point here? Look, you could have published a good paper by just talking about this one table here, right? And then in some communities, this flies, this is okay. In an applied universe, this doesn't work. So again, we are not hiring people who can just do this, right? If you're not spending time to understand all the nuances, right? If you're in this room, you should know the most about your product. If somebody else can do a deep dive and find out something more about you, then at least on my bar of MLE, you're not there, you're not cutting it, right? So this is why, right? I mean, if you start reading some of these papers from, look, I mean, go for ICLR, ICML for the model nuances, come back to SIGIR, WWW, KDD for the evaluation nuances. And the people who can do best of both the worlds, I think you will be paid like in multiples of the other people. I mean, at least in the current world. I mean, things are changing. Maybe MLEs go out of business. Hopefully not. If so, then we're all screwed anyway. But yeah, I think like focusing on the evaluation. My point was that it was a very big detour, and I was unable to move this guy out of it. I think I put it here. Yeah. So long story short, the point was, look, I've shown you some enough examples through the extent that Vibhuti was able to predict what I'm going to say next. So there is value in you making that prediction and spending time understanding the problem domain. What next? Quickly looking at a deep learning model for in-session personalization. I've talked about that a few times now, right? It just makes sense for me to at least talk about one of those models. So again, I have a very simple use case. I have a user session, right? I have a user and then they have been looking at a few sessions. Now, what I can do is I can look at a bunch of these sessions, combine them in an attention mechanism and develop a dynamic user embedding. Now I get to dictate how long do I go back? Do I go back 1 year, 1 month, 6 months, 2 weeks, 7 days, 2 days, whatever. Then I can develop this mini neural network and get a dynamic user embedding. What next I can do is, oh, you know what? I can look at that and make it part of my recommendation strategy itself, right? And then using that, I can decide what recommendations do I show here. So again, I'm not gonna, this is working, yeah. I'm not gonna talk about what exactly is the RL model going on here, but the point is, I can look at each session. I mean, remember a few slides ago, the short attention model across session, that gives me a representation. That becomes the S over here. Across sessions, it becomes a dynamic user embedding. Across candidates, it becomes a feedback model, and then it passes along. So there's a sequence of ML models. I mean, sequence of neural modules, which you can stack together and train end to end. And that will give you an in-session personalization view. Cool, so we are good on time. So this completes the third part in slightly rushed format, but the two takeaway points are like, you got to learn user representations, and by now we know a few approaches of doing that. And you got to spend time in understanding your problem domain and learn about the users, and you can start doing some in-session personalization. Finally, we're on to the last bit, and we have a shot at completing the course actually. So you're going to see all the content anyway. Any high-level questions? So the great question is like, I mean, if multiple people are using the same account, then how can we learn these representations, and how do we disentangle that, right? And I can see the happiness on everyone's face here, because the questions are good. And there's an actual paper from Paul Bennett and others at Microsoft Research, where they're saying that can I disentangle the, I mean, like your Spotify, your Google Home is getting used by your family members, you and others, and hopefully the model should be good at realizing that the devotion music being listened to is not Rishabh listening to it, but his parents actually doing that. So I think like there are ways of doing that, and you'll have to treat it as a separate ML problem. That if I look at a history, a set of items, right? And then I can look at maybe some patterns across these. And if there is some coherence, maybe, oh, maybe every morning there is a set of music which gets played. So then that may be a different user taste view. I don't think we can say that it's a different user, but at least like the multi-view representation I was talking about, right? Maybe then if I have a way to decide that, hey, you know what? There is a devotion side to this user. There is a baby side to this user, is listening to like lullaby music or whatever. And then there is this hip hop side, right? It may come in from one user, multiple users regardless. But if I have a multi-view representation in the in-session personalization, right? I mean, we were talking about this here, or in the previous slide, the attention. I mean, actually, it's worth going back. Give me a second. In this network here, right? If I know that if there is a history, if I have multiple views here, imagine that there's multiple views here, then I can bring that in, right? That, hey, the recent interaction suggests that among these three views I might have, this view is a lot more important, right? So you can have a gating mechanism here. We talked about gating mechanisms earlier, right? So this is an idea for writing a new neural network paper, right? At least for an applied conference. That, look, I have multiple views. I don't know which view is useful right now, right? Again, this will solve your problem that maybe this use for the same user or the users, I don't care. But then if I have this view, I can have a attention gating mechanism here, which can then focus on like, hey, this history is relevant. And let's kind of use that for decision making. So I think that has been done in a non-neural way. I don't think there is a paper in the neural network world of today which does it. So again, I don't think it's a very, very great, I mean, it is a great paper to write because it doesn't exist, at least in an attention-based view. But I think some of these ideas have been explored. But it's a great research to pursue nonetheless. Cool. So how's life? Yeah, go ahead. Sorry, you started and then the dog intervened. It's hard for me to. Yes, now. I'm so sorry, I'm getting distracted by, how do the apps? Right, 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 right. I love that. I mean, look, taking a step back, right? Look at the expectations change, man. Like at the start, right? We are training one model like maybe once a year. There's a huge matrix factorization. I'm decomposing it maybe like a week's time. And now the expectation is that, hey, 10 minutes ago, I had a view, right? And you're not updating. And in the last 10 minutes, I have new information. So I love that fact that you guys are so, what is it called? Entitled, right? You feel entitled that, you know what, like, why not 10 minutes, right? Kidding aside, I think like it's a great question. I mean, one of the things which we want to do is like in-session personalization should be very real time. So at least on my team, right, Nilesh and Rohit and all, if you're listening, if not, then I'll at least code this 30-second and send a trailer to you. We look at like the last, we have the ability to look at the last, up until the last 40 seconds, right? So 40 to 50 seconds, right? I mean, so then I won't have the view of the last two video clips, 30-second clips, right? But then like up until then, I have the real-time aspects. So there is a huge system design aspect to it, that how do you make it so real-time aware? And there's a big difference here, right? I mean, when I have real-time, it's not about real-time retraining the feature, retraining the model. It's about real-time getting the feature and then using that to make a different decision, right? And I think there's a nice point here on, again, this is a personal thing. I think like with the next statement, my current and previous employers both will be equally upset. So I honestly think off the record, I mean, whatever that means in a recording setting, but Spotify does really well on long-term views. And it took us a really long time to do well on real time. To the extent that I don't think we're still there. ShareChat does really well on short, like real time, short term. But I think we don't have any, I will be very honest, right? I don't have a 6-month long representation for the users. I come into the company, I'm used to Spotify base because music culture is like, I mean, music is like very long-term preferences, right? I mean, content catalog is stable and all. So I look at these like 6 months, I've been using these 6-month vectors, 1-week vectors. Here, there is no 6-month vector. I'm like, oh, why don't we have 6-month vectors? Like, oh, we have real time. So then I was like, oh, okay, this makes sense. I mean, the content catalog is fresh, so then we need to do that. But I think like at both places, both should be available. And here's a very nice information, right? I mean, look, old users on a platform, old users, not like old in age, right? I mean, people on the near side of the stage are older slightly than others, especially people on the stage. I can't comment on people sitting. But essentially like old users on the platform is like who have a nice platform age. So they have a long-term view, right? If you have a very real-time system, then you're doing great justice to new users and like pseudo new users. But then you start not incorporating that long-term view for the old users, right? So I think then depends on where the focus is. If you are a team who is focused on new users, new user activation and new user success journey, you're talking about 1 hour ago post life cycle. Some posts are early, some posts are dying out. How do we bring it back from the dead? All the zombie stuff, right? Same on user front. How are we doing on users? What are the projects for the users who are new users? That's different than old users. For old users, I need a lot more long-term history, and I think we should develop that. Yeah, I think this is a great. I don't know why this question is popping up. I mean, it's a good question. I think somebody also asked this question like in the break as well. The question is that a user is active on the platform, right? And they were active up until 1 month ago, and then they disappeared. Like something happened, life happened. They went on a trek to Leh Ladakh with friends, whatever, and then they came back, right, in a month. Now, should I still show old preferences or new? I think it's a combination of both, which is that, hey, I mean, that's the only data I have. But then, like the current trends, at least on ShareChat and Moz, will be very different, right? So again, recently, like I mean, the Japanese Prime Minister, ex-Prime Minister, all that news is happening, right? So then maybe that's something which I'll kind of prioritize. So there's a tension between content personalization, content targeting, and user personalization. So especially in search domain, it's easy, right? You're searching for something and that's fine. But in a recommendation domain, I think like more recent the entire content has changed, right? Especially on short videos. So I mean, long-term views, maybe, I mean, high level, right? High level, you're interested in these genres. You're interested in maybe devotion as a category. You're interested in gaming videos, like Twitch videos and all that, right? So maybe that interest remains. But then I do have new content in that category. So then I'll start recommending you that, right? So I think like there is a lot of transfer of preferences across time. So, I mean, recent stuff from your interacted genres is what we end up recommending. We have the BitSync Cloud brag.
Hey, can I ask a question?
Cool. Two good things happened. It's worth a clap. So we have the BitSync Cloud brag. And we have a question which is from remote. Yes, please.
So you just mentioned like in Spotify, you guys focused on the long-term aspect side of it because music generally has a very long-term preferences and all.
Right.
Whereas in shared chat, you focus on short-term side of things. But is it purely short-term or do you have some component of long-term as well? Because even for like short-term videos also, like I think a lot of there would be some long-term component also, right?
Yes, I think it's a great question. I think like what I meant to say was that the need for, I mean, on a Spotify-like platform, the need for long-term profile is higher because of nostalgic content, nostalgic music, and familiarity and all that, right? The need for real-time adaptation on short video platform is higher. But that said, I think on share chat, on short video platforms, we should do both, right? Have a long-term view. But if you were to give me an option of have only one, then I'll rather have a short-term view. Why? Because the in-session personalization is important, but also because I get a lot of shots at the problem. And I think this is a point we haven't touched upon up until now. Look, in a movie recommendation scene, right? You watch like 3 movies in 10 days, right? So I have only 3 shots. In music, music is 180 seconds, right? 3 minutes, 4 minutes. So if you have a 1-hour session, you're going to listen to like 10, 15 music songs, right? So I have like 10 shots at the problem. But if you stay back for 10 minutes on a short video platform, I have a shot at 40 recommendations to you, right? So I can fail more and quickly recover, right? If you start watching a crap movie, after 15 minutes you hate it, you've almost finished your food and you are pissed off that, oh shit, this is a bad recommendation, I hate it, right? So again, the cost of failure is very high in a large consumption like. So people who are not online, I mean, there's some dogs who are very curious to attend recommendations as well. So they're talking in their own vocabulary. And there's some dissatisfaction going on there apparently. But yeah, essentially, like, I mean, you're right that like ideally we should have a long-term view even on share chat. But I think like the default which people will start with is like, hey, I need to be more real time. And once you have the default, then you might just kind of go and expand to long-term vectors. And this to me is like, I mean, Akashwadi types question, right? I mean, like the God asking questions from like, oh. Yeah, I mean, yeah. So YouTube Shorts is a short. I mean, that's literally TikTok, right? Just inside YouTube. But, Achha, just YouTube itself. Right. Right. Yes, great problems for their product managers to solve, right? I mean, yeah, totally right. I mean, now it's great. I mean, I'm really proud of the fact that you're able to identify these product nuances. That YouTube has a bunch of very mixed content, right? So then the modelings and the system design aspects and the problem formulation aspect there will need a different thinking, right? So the best engineer, the best scientist from TikTok may not be the best, become immediately most useful on YouTube because the problem domain and the nuances are different, right? But one good thing which has happened is that now you're able to take a step out, right? And look at cross-platform, right? I think this is a great win to have because it took me a long time to understand these cross-product nuances. Because look, you go in, you spend 5 years at Spotify, you're zoomed in on one content, right? Very rarely do people take a step back and look at, hey, what's going on, right? But I think like you're able to take a step back, and I think like that's really like commendable. I think, I mean, not just for you, I mean, for you as well, but I think the group is able to take a step back and think through. That's good. No, behind you. Sorry, there's a preference order. Yeah, I think this is where, I mean, I'll rather rely on the neural network to do that attention weighing across features. And again, I don't think there's a fixed answer to this, right? Because it's very heavily context dependent. I mean, this is where like you want feature interactions to play out. One thing which we just mentioned verbally was that do we have ML models which can do that feature crossing, feature interaction? Now, context is important, like time of day, day of the week, right? The success of that content in that time context is important. So again, we never talked about it, but one of the features which we have in most of these systems is what's the success? I mean, wishes, right? Good morning wishes. I mean, that's at least up until a few months ago, that was big on ShareChat. So the success of good morning wishes is high in the morning, but also late at night, right? Because people are literally like saving stuff for tomorrow. And you'll be surprised at what people end up doing. But in the evening, in the afternoon, that's not right. So then you're looking at the success rate of content in that time frame and then there's a user level play here that this user may or may not like this. Again, you might have different morning behaviors than somebody else, right? So I don't think there is a fixed one size all fits solution here. But the good thing is like, look, maybe there are groups of users, groups of content wherein this is generalizable. So if I have a rich enough training data set, then the model can try to figure it out that, hey, for this context, this is the feature weighing I should do. This is the feature interactions. And once you have a neural network or whatever model, right, it can start assigning these weights. So this is what the gating and the attention mechanisms are doing, right? It's not a static weights every time to the experts, right? It's kind of conditioned on a bunch of signals. And that's what like deep learning models with the additional parameters, right? So I think one of the ways to interpret these additional parameters are that, hey, this is a richer model. It can think and reason about those situations as well, because you are dedicating some new parameters to do that, right? And in a limited capacity model, I don't have these parameters. I only have 10 parameters. I've deployed them. They're doing this, right? Any new task, I don't have parameters to model it.
One more question, like
There's a question from God. We can't deny that. Yes, please go ahead.
that's very specific to ShareChat. How do you guys manage inappropriate content, considering like those kind of stuff generally have the tendency to go on trend faster?
Yeah. I think like that's a great question. I mean, like we slightly discussed that in one of the break sessions, which was what do you do with like almost sleazy content or almost NSFW content or other. So content moderation is a big investment. I think like one of the things which we really emphasize, I mean, not just us, right? I mean, Spotify, YouTube, a bunch of other companies, right? They're specifying a lot on content moderation, and not just machines, but there are humans. I mean, especially in China, right? I mean, there is a government mandate to have humans look at the content before it gets out, so that they can do some surveillance and all that, like government level interventions. But I think like there's a lot of importance to make sure that the content understanding is flagging the right content, and then you have human experts looking at it and then allowing it in the system. Now it could happen that some content, given the fast pace, right, short video comes in, we start showing it to 100 users, and then like some of that slips through the crack, right? So this is where there's a very nice discussion on precision recall, that how much false positive rates are you okay to tolerate. And this comes at a trade-off, right? If you want entire coverage, if you want perfect recall on NS like non-safe content, then you're going to lose out on some good content, right? They will falsely get identified as bad content. So then you are kind of being in like you're doing unfair stuff to them, right? And at the same time, if you're okay that, oh, I don't want to like get any criminal, any like whatever, like any bad content, like okay, I don't want fresh good content to get tagged as bad, then you're gonna deal with that precision problem at the cost of recall, right? So again, this is a system design. Everybody, each system designer should kind of independently argue what is good and bad for them. But again, a nice example, right? We keep seeing that precision recall in ML models is important. This is where like it's actually important in the policy making. Like what are you okay with? Maybe in certain cases, I don't want any of the bad content to show up. And if it means that some good content gets flagged, great, I don't mind, right? But then the other cases would be, no. At some of these, it's okay. I don't want good content to miss out. So that's a different policy. Look, here the model is going to be the same, right? But what threshold do you use to filter this out? That varies. I mean, you can have a threshold of 0.9 and do really high on precision at the cost of recall, and that's fair. Or you could have a very low threshold of 0.2 and do crap on precision, but very high on recall, same ML model, but then you're just kind of using it differently in the decision-making process. You had a question. Yeah, I think that's a good point. I mean, I'm not sure if it is, if it isn't, because I'm not aware, at least while it's getting recorded, of companies using that data for policy or decision making. But then, like, I mean, similar to the podcast music example, right? If I know, look, I think like the apps you have on your phone, right, give away a lot of information. I don't know if companies are using it or not, but then if you have a running app involved, I mean, running Strava and all that, right? That means like you're pro running, you're gonna slightly be more athletic. Then the kind of recommendations, the kind of products, the kind of music I can recommend to you is very different. If you have some groceries or some like baby diaper apps installed, right? Then this is gonna be like, it tells me that, oh, you're in that age bucket, you're married, you're doing this and all that, right? So I think like just a few apps can tell me a lot about the kind of content which you would want to see. But are companies using that or not? At least I, on my iPhone, I do get notification that, hey, allow them to track. My reply is like, no, why would you do that? Yeah, yeah, right, right. Yes, great point. I think like, I mean, look, the specialist generalist is you have to define at what granularity are you measuring that, right? So it need not be on the music track space. It could be one level about tags or topics or categories, right? So you as a system designer get to decide at what abstraction am I dealing with. If you're dealing with posts, then like posts are like very like non-timeless on the platform. But then I'd rather deal with tags or topics or some genres and then define the specificity or generality on that. There's a question. Yeah. I actually, when I looked at it, I was like, oh, there was a question which I thought we'll answer in the break. We never. Right, 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 right. Yeah, right. And once you're there, like your job is done, I'm going to take it back. Right, right. Yes. Okay. I like the story and the question is nice. So the question, the story is that, hey, I mean, we were talking 1 hour ago before we had tasty food, at least we had here. Remote people, I don't know what you ate. But essentially, like we were talking about the Google Pay rewards, and then a user is not transacting, I'll give them 15% off. Then they start interacting, I give them 10%, 5%, and 2% cashback, right? But how, I mean, does the system understand that the habit is inculcated already? So in my team, I don't have a, I mean, even at Spotify, I don't have a way to identify that habit right now. But again, like this is one of those problems, like learn about the users, like diversity and all, right? Is this habit already formed? Then you can have a score. One of the things which we did do was user artist connection. Like, have you formed a connection with this artist? Now that's a long-term thing, right? Because to form a connection, I need you to listen to at least X unique songs from the artist over a period of time. So that's a long-term thing which we track over a period of time. That, hey, have you formed a connection yet? If not, then are you walking towards forming that connection? And that's kind of a habit between user and a creator, which we will track. But I think this is one of those problems, right? That you can cast it as a separate problem and then develop a time-aware longitudinal model to do that. Yes. And again, like different policies for different users means that, again, and you're going to learn, right? That I reduce it and then suddenly you start churning out again, right? So then, I mean, the overall high level question is then like, are you even worth me giving the discounts to, right? Because if you're only on my platform with a 15% discount, then I don't want to create a habit for you, right? I just kind of abandon you. There are other users whom I might focus on, because you have a limited budget. You're going to spend X amount of money only, right? And I want to spend money on people who I can reduce over a period of time. If for you I cannot reduce it, then I'll have to stop. But then is the model able to do that? I mean, you'll have to architect that model. That has to have that long-term view of the user as well. So the context in the contextual management model, all of that has to incorporate that long-term aspect, which I don't think it does right now. It would be part of user trajectory, but then in your reward design, right? It won't be in the reward, it will be in the context signal that, hey, what's the history of user response to this, right? What happened when I increase it? What happens when I decrease it? And all of that will tell me more about the context so that I can make a different decision there. Cool. Let's move on and wrap up so that you have a lot of like good bags, which we've gotten printed for the first time. So we can hopefully take some of those as well. So people offline, we have a few bags which are really nice looking here, which you may or may not have access to. Okay, taking a step back, right? Where are we? We are in the last leg, right? So thanks for staying awake, half awake, 70% awake. We've looked at recommendations. The energy value in the room has slightly gone down post lunch, expected. I think like I've used up the quota of my words for my entire India trip. So tomorrow onwards, until I go back to London, I think even if I say 0 words, my average will still remain high. So we've looked at like multi-stage recommendations, right? We've looked at ML approaches, learning from user interactions, and now let's focus on evaluation, right? And I think this is a very interesting and very underappreciated. And I think you're going to start seeing, right? I mean, like you see the bulk of the meat was part 2, right? And then it's more about English intuitions. I think like there's a general trend here as well, right? As long as you are half awake, you should be able to grab what's going on. It's fine. It's been a long day for people anyway. So yeah, I mean, I hope this is from Lord Kevin, but I've seen this enough times. I just stole it. To measure is to know. If you cannot measure it, you cannot improve it. So what do we do? Like accuracy is something which you use, right? I mean, you develop an ML model, you try to measure its performance, right? What people end up doing is like, they measure accuracy, precision, recall. What other metrics have you been using? Like offline metrics. Throw some names at me. Let's wake up. Yeah. F1 score, yeah. What else? Sorry? R square. R square, okay. What else? What other metrics have people been using? Sorry? I hear the voice, I don't know the person. AUC, yeah, AUC, yeah. ROCS. Others? I need some other good metrics. Sorry? Blue score, yeah, that's nice. I mean, blue score is a new metric, which we haven't talked about. Right? Summarization and all that, use that. Rouge, yeah. Yeah, this guy just generalized that, oh, you know what, I can create my own metrics. And that's a superset of all the answers which anybody in the room can give. Great. I mean, I like it. Yeah, it's fair enough. But let's be a bit more specific. I should be talking about that, not you. But any other metric? Any ranking metrics in the room? So me and Professor Andaman are waiting to hear that phrase which starts with N. Yeah. Anybody heard NDCG at all? NDCG, anybody? Oh, nobody has. Oh, shit. Okay, cool. Oh, that's fair then. Okay. So, I mean, look, accuracy, precision, these are all point-based metrics, right? You make a prediction, is it correct or not, right? But the moment you look at rankings, you have different metrics. Like how, I give you a list, right? I mean, I give you a list, and in that list, the track which you hated is ranked 1, right? I give you another list, the track which you hated is ranked 7. Which of these lists is better? List 1, list 2. The second, right? Why? Because I'm ranking the crappy track later on. How do you know that? Because you've looked at the list, right? And then you come back with a metric. So that's what similarly what NDCG does, right? Normalized discounted gains. And again, I'm sorry, I don't know the slides for that because I stupidly assumed few stuff here. But again, I mean, even NDCG and all, right? These are ranking measures, but then the point is they're not enough. Why? Because just optimizing for this doesn't increase user satisfaction. And this is the key point, right? We got to do what you were suggesting, right? That develop metrics which are more product centric. And that's what we are going to do. So one of the things, right? I mean, let's look at how some of this data is calculated. So again, what happens is, again, refresh if you have been sleeping all along, if you didn't take away anything up until now, the last 15, 20 minutes of this talk are very self-contained in itself, right? The question then becomes, if you go to any internship, do any job, you are gonna have some log data, right? So you have the user context, you have the production recommendation model, you're taking some action, the users interacting, and then you log all of it out. Now, this is the log data which you are going to use for your offline evaluation. You know that this is what the user did in the last 1 week, and I can replay that, right? I know that you skip this track, you stream this track. Now, does my ranker rank this skip track higher or lower, right? I can compare different rankers, have different metrics. So that's a typical evaluation setting, right? You log some data, you replay that, and then you see how your new ranker is performing, and then you calculate metric and then decide what is the winner. So again, nothing fancy here. This is how exactly the current everybody is offline evaluating these days. Any questions here? Because this is going to be used later on. Is it clear? 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 Cool. Cool. I think the point I want to make is, let's go in from a world of model evaluation to behavioral metrics, right? I mean, we looked at precision recall, AUC, ranking metrics like NDCG, but then I want to start looking at behavioral metrics like clicks, like shares, but also dwell time, session length, and also gestures, eye tracking. Let's start looking at what does this world look like. So I think, like, again, there are few forms of evaluation. One is explicit feedback. Again, we're not going to go into specifics of each. Explicit is asking the users, asking the judges, hey, this is good or not, right? So we ask for explicit label, get that annotated. Or I can do a lab study. I can develop a new UI, invite people in, pay them $50. They spend 1 hour using my app, and then we answer questions, lab study. I can do a field study as well. Like I can go out, do user research, like randomly meet people on Delhi Metro. Oh, you're using ShareChat. Oh, you're using Spotify. Ask some questions, right? Or I can do in-app surveys. In-app survey is something which we used for the intent project, which we are talking about. So in-app survey, I think it's like somebody had a great point in the break. They mentioned that, hey, in-app survey, what happens is you're using the app. Suddenly there's a pop-up says, hey, how are you liking the session? You were asking this question, right? Yeah, great. So I think in the in-app survey, I'm on YouTube, I'm on Spotify, I consume for 15 minutes. Suddenly there's a pop-up and it says that, hey, are you liking it or not? It's good, right? Because I can do that in-app survey to 4 million users, 10 million users, right? Usually the click-through rate of that is close to 4-5%. So if I launch it on 10 million users, I get like 400,000 responses. And that's big enough for me to train models, because deep learning world, 400K responses is good. The problem is in-app surveys are very, they will stop your session, right? They're breaking your engagement because it's very annoying, right? You're doing something, maybe you're on the brinks of completing a session or reaching satisfaction, and suddenly you ask. And then it's like, hey, I mean, let me complete the session and all, right? So there's a bunch of nuances and all that, like, I mean, you deal with all these problems. But then, I mean, they do give you that data, and then we did train a model on top of it. So this is fairly common. If you look at Facebook, Facebook will ask you these in-app surveys. YouTube will ask you this. Spotify will ask you this. Other thing is email surveys as well. Like we've done a lot of email reviews at Spotify, especially for Discover Weekly, because Discover Weekly is generated once a week, right? The question is like, I cannot do that for all playlists because you may not remember. You saw that email today, your session is 2 days ago. I don't expect you to remember, were you happy 2 days ago or not, right? I mean, I don't expect you to remember whether in life you were happy, leave alone the Spotify use case. But this is all explicit, right? I mean, explicitly asking whether the user is happy or not. The other is implicit, right? We've talked about that in the earlier question when we're talking in the first session. So then we want to understand user engagement to infer satisfaction. So this is where like people do very fancy stuff. So today in the morning, somebody was talking about logging, right? Now comes in, right? Look at what all people log. Now this is mouse cursor movement. So when you go to the search engine page, you know that the user mouse is hovering here, 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 or the user is going here, right? Now, if you look at this, right, this is a lot more successful session. Why? You type in a query, You go to the first result, you found what you wanted, and then you left. Here, you didn't like it, you move around, move around, move around. So that means you're unhappy. So if I'm able to track your mouse movement, I can infer whether you are happy or not. What is this data? This data means the JavaScript on your browsers is logging the x, y, t. X, y is the real state, xy on your homepage, and t is the time, right? And then I can draw these sequences. So this is logged for all the queries across all the users across all the time, right? So when I went to Microsoft Research 2015, I literally saw the entire video of this cursor movement. For any query in the world, they have this logged. And I was blown apart. That's level of granularity in the data I've never seen. Why? Because imagine, like, I mean, 2015, somebody in Noida started querying, and then they type in the query is getting written, and then there is like a logging, and then there is all that, right? So that's the level of logging people end up doing. So if you guys are asking about, hey, are we logging interactions? You're logging everything, right? And this is huge, because to do this, you have to have a lot of JavaScript, and you have to have something called box models, because you can log that XY, that's fine. But then you also want to log what is behind that XY, right? Is it a news widget? If you go to Google search, right? I mean, I'm not going to search because I don't trust the answer, it'll throw up. But you go to results, there's some news, there's some Wikipedia panel on the right, there's something, right? So actually, why not? I mean, I can at least safely search myself. Man, this sucks. So at least in London, I didn't know that there is a people which is another Rishabh. This is bad. At least the images are also not personalized well. Man, I gotta kill these people. Cool. I mean, if you look at this, right? So again, like, I mean, if I can log the x, y, but then I need to know that, hey, is there an image panel over here? Is there some results? Is there a Wikipedia panel on the right and all, right? So I need to know what exactly is the content getting displayed. How do I go back to my slides? Yeah. So you gotta log the activity, but also the content, at least the box plot of content. I'll tell you what the box plot is. Now, similar, you can do that on the mobile screen. On the mobile screen, there's no mouse pointer, but then I do know that, like, what is your gestures, right? Are you zooming in, zooming out, swiping up, swiping down, right? And the velocity of your scroll. If the velocity of scroll is high, then that means the content in between you didn't consume. On the Spotify homepage, this was a very big feature for us, right? To understand whether you were happy or not. Like, I show you a playlist at the top, you didn't like, you didn't interact. Now, maybe you didn't like it, or maybe you didn't see it. Right? Was it on your screen for enough number of time, enough sufficient time? Did you explicitly look at it and decide I'm not going to stream it, or did you just not notice? So if you're logging that scroll velocity, right, then that will tell you that, hey, this content was visible only for a fraction, then the user wouldn't have consumed it. This is where you're going to assign the label of 1 and 0s. If it was on the real state for a long time and the user didn't like it, that means it's a 0. And the other content should not get a 0, right? So suddenly the ML model you are training, right, it directly is impacted by this feature. So are you training it on junk data, which is like 0s and 1s, which are like noisy, or is it like very, very well curated? So same like on other, right? I mean, like, we can start then developing motifs. So motif is a cursor. I mean, motif is a subsequence discovery work. And then I can start doing this motive understanding. There's a bunch of work there. Something which we did during one of my internships was that, hey, this is the box plot I was talking about, that you have the web result page here, and then you have the corresponding box plot there. You don't care about what result there is. At least you know that there's a Wikipedia page, there's an image panel and all, and then I can log this. From that log, I can get these sequences. From that sequence, I can get a metric. So again, a bunch of implicit signal with a large amount of logging. Satisfaction prediction, I think we've talked about that, and then intent problem. That, hey, I want to predict satisfaction, tell me what the user was doing, and I'm going to predict the intent. So again, I can collect some data using in-apps, I can train a model, and then apply the trained model in a different setting. I'm intentionally rushing through this, but the one point I want to make here is that sometimes the satisfaction metric is an output of an ML model itself. And hopefully this is not surprising to you, because the intent paper from Spotify I was talking about, that was an ML model to predict satisfaction, whether the user was happy or not, right? So that to evaluate another ML model. So this is slightly one level meta, right? That you have to evaluate ML models, and then you use the output of an ML model as a metric. Again, I'm not going to spend too much time on it, but essentially this is what people end up doing, right? I mean, there's a bunch of, sorry, where is it? Yeah, there's a bunch of explicit data, implicit data, satisfaction predictions, all of it to do what? to do better offline-online correlation. And here is the example. So A/B testing is something which every company does, right? And I think like if you're going to go to the industry, internships or full-time, this is something you definitely should know. So one of the two books which one of you should be getting as a reward for posting content on LinkedIn and Twitter, right? The book on the right side was the experimentation book that talks about A/B test design and everything. So A/B testing is a big thing and we should all be aware of it. Just a quick raise of hands on how many of you know what an A/B test is. No, not internal, external. Yeah, but where? I mean, you don't have to answer it. I just want to know like how many of you actually know A/B testing. Do you guys know A/B testing? Hearing it for the first time? Cool, cool. I think this is yeah, that's a revelation. I was expecting. Oh yeah, okay, cool. Yeah, okay. Yeah, so I'm not going to talk about A/B testing because I think like the expert is going to talk about that. I think like the one level view here is that, look, I mean, I have to test a new feature, right? I mean, maybe it's like, hey, should I show this model or show that model? Or maybe should I change this icon, change that something, right? Anything which I want to change on my app, what I will do is I will divide my users randomly into A and B and then deploy it, right? So basically the entire stack remains the same. User group A gets to see model 1, user group B gets to see model 2, and then I look at the difference between the two. And then if that difference is positive, that means B is much better than A, right? The metric for user group B is better than metric than for user group A. That means model 2 is better than model 1. So that's the typical A/B testing setup we have. Everybody in the industry is running these A/B tests. And whenever, look, pay attention when he's talking about that next week, right? Because if you don't know that, your earning capacity will get reduced. I'm sorry to link education to earning capacity here. But look, I mean, everybody in the industry is like doing it left, right, and center. Now you know what A/B testing is? Raise of hands who now know what A/B testing is. Still not 100%, no? It should still be 100% now. Cool, okay, good enough. Yeah, so the only thing is like I have, let's say I have 100 million users, 50 million users get A, 15 million users get B, and I look at the difference. The key part over here is that initial split is random. It's not biased. Because it's random, it will have a lot of nice properties, which hopefully sometime next week you're going to talk about. But the question becomes, how many variants can I test, right? I mean, again, like I have a team, my 100+ people in the AI org, they're all testing, they all have ideas. How do we test, right? So this is usually what happens. I have an idea, I implement it, I maybe do an A/B test and try to find and deploy, right? This is the experimentation cycle. And maybe I can do F number of A/B tests per month, right? The more the F is, the more shots I have at the problem, right? And the more the chances of success are. So what we end up doing is like, we say that, hey, I mean, let's have a good offline evaluation setup and let's do 100 times experiments on the offline version, right? So then I will do 10x, 100x more experiments in the offline test, find out the best performing ones, and then do that A/B test, right? So now suddenly my experimentation agility is very, very high. So I can try a lot more models. I can try and avoid utilizing the A/B testing traffic unnecessarily, right? Why? Because like you try random string, users get unhappy, so you pay a cost. And there's a huge engineering cost, right? If I have a crap model and I will do a lot of engineering to get it out and it sucks, I'll rather know that it sucks before than actually getting it deployed, right? So how do we do this? The question here, very important, is that the offline and online correlation should be high. Just this statement, right? Just this statement is a very important topic in the entire industry. And I can say this right now because I'm living with the pain. We need a lot more people in the Indian talent space, in the Indian industry, to become a lot more aware of the A/B testing nuances and offline-online correlation. And this is a trend which is going to happen. Like ShareChat 2019 were like 20-30 ML engineers. Now we have 100+. Meesho now is at 20-30 ML engineers. Maybe in a year or two, they will be 100+. You see a lot of big companies coming up, getting a lot of money, starting ML teams, and then they need these people who are good on experimentation. So there is a trend which is here to remain. So these are one of the skill sets which if you pick up on, there is going to be a lot of demand for this skill set, and there's a very short supply because even I have had a very hard time hiring for this role, decision scientist role here. So hopefully that should be motivating enough for you to pay attention. But I need two properties of my offline evaluation to be good. One is that if my offline eval says that model 2 is better than model 1, then in the actual A/B test, I should see that model 2 is actually better than model 1, right? So that's directionally. That you say that model 2 is better, then model 2 is actually better. What would be worse is that my offline says, hey, model 2 is better than model 1. I test it online. It comes out to be opposite, that model 1 is better than model 2. So then I have a very stupid offline evaluation setup, right? So I need that directionality correctness, that it's correct directionally, right? I'm sorry, this is a lot of black and white in the image. But at least the offline and online should be correlated directionally. If you say that model 3 is better than model 2 is better than model 1 in the offline evaluation, in the A/B test, this should hold. The other thing is sensitivity, which is my offline evaluation says model 2 is better than model 1 by 4%, right? Then in the actual A/B test, is it a 4% change? Is it a 2% change? Is it an 8% change? How sensitive are you? How sensitive are you able to measure the delta, right? But it's fine. I mean, sensitivity, if it's not there, it's okay. But directionally, at least, like if you have an offline evaluation which is not directionally correlated, then just throw that away, right? It's useless. Or you start doing the opposite of what your offline evaluation suggests. So this is very, very heavily needed. Building on top of it, I'm just going to introduce a few terms here today, because I don't think we can talk about any of that in detail. There is an entire tutorial at SIGIR on these topics itself. We've done some publications on this. Just going to introduce the notion so that you're aware. If you hear about it later on, you can relate to it. At least, is this clear? I think this is a very important point. Forget about all the models, neural architectures, everything, right? Offline, online correlation, at least I want this class to be aware and acknowledge that this is a good problem. Otherwise, I would have failed as an instructor. So I'm going to take it very personally. So raise of hands who know what an offline, online correlation problem is. I'm not going to move on until I see all the hands up. Otherwise, I'm going to keep on explaining the same thing again and again. I still don't see a lot of hands up. I think like people are not, what Thakur from Sholay, right? I mean, you have hands raising up. Cool. So this is important, right? I mean, having good offline, online correlation is important for every industry, all the MLEs, right? Now comes in what is going on. How do we get offline evaluation? So remember the first slide I was talking, right? We had, we have the model, I log the data, and then I use that data to evaluate. Just bear with me for 5 more minutes and we're going to wrap up, right? So last 5 minutes, let's kind of push it and cross the finish line. And this is slightly more tricky. I mean, high level understanding is not tricky. The math is tricky. We're not going to cover the math conveniently. So we have the production recommendation, right? I have the policy, pi. Policy is like what is making the decision, what to show to the user. And I have the listening behavior. I collect this log data that I showed this to you yesterday. You like this track, you didn't like this track, you like this track, you streamed so much. So I have all that interaction data. Now I want to use that to evaluate a new recommendation policy, right? So today, like somebody, Vibhuti is like, oh, you know what? I have this tolerance, the intent, right? I have an intent model. I can use the intent model to make better decisions. Now I have a new policy here. Now I want to evaluate this policy. How do I do that? I will use this data, right? Because that's the only data I have. So I'm going to start using this data to evaluate a new recommendation model. The problem is these two can be very, very different, right? Now assume like this model is very pro-creator, right? It's saying not pro-creator, but like very friendly towards creators, right? So it says that, hey, I mean, I'm going to show a lot of tail creators. But in the log data, this model never showed any tail creator. So in the log data, I have no data wherein I have shown a tail creator, right? So then how do I evaluate this model? Because, I mean, hey, you were collecting this data last week, right? And the last week's recommendation model always kind of shown popular content, right? I never showed any tail content. I never showed any niche creator, any unknown creator. I never showed them. So now how do I evaluate a new model when I don't even have that data? So this is a problem, right? I mean, the data I'm using for evaluating is heavily biased towards the production policy because the data is collected on the model you had last week. The model you had last week gave the users that recommendation. Then you collect that data. So now I'm handicapped, right? I never had a model show this content before, so I cannot evaluate it. Do you acknowledge the problem here? Cool. I see a lot of hands, a lot of heads nodding. Great. Now this is a problem. So this is why we need a special log data. So I think like this is where I'm kind of leaving you on a climax. I'm going to mention the problem. right? Make you acknowledge the problem, hand wave a solution, and then move on. Because I think this deserves a proper tutorial in itself. Maybe at some point we can talk about it. But this special log data is this randomized data. Randomized data, IPS, inverse propensity scoring, logging action policies, all of that, right? I mean, you'll see here a lot of these terms in the industry. If you're reading this in the industry, if you're in a talk which is talking about any of these words, then you're in the right room. Because I think the people who know about this, they know what they're doing, right? I mean, suddenly your respect for that person should go up. Indirect way of saying that, hey, I'm talking about this, you're in this room, so maybe you're in the right room, right? But essentially what we do is, I mean, can I log with what score did you show this, right? That's one. And can I collect some randomized data? In the random setting, because I'm picking up random content, right? Sometimes I would have picked up some tail creator, right? And then showed it. Sometimes I would have picked up some non-popular niche content category and shown it to the user. So given enough randomization, this log data is representative enough. It may not be bulk, but there is some data in here which is going to be useful for any new policy I have. Why? Because it's random, right? Enough randomization means everything is in there. It may not be in large quantities, but it is in there. The second step is, if it's in there, but it's not as much, how do I give it enough weight? So this is where things like inverse propensity weighing comes in, IPS. So again, not going to talk about that, but IPS is 1 upon probability of taking the action. So if there is a decision which is very rarely present, right, then you can upweigh it. I mean, very intuitively, you can say that, hey, you know what, I only have it a few times, but I'm gonna, all the other decisions are many, many times. I'm gonna upweigh the examples here. When you upweigh it, your uncertainty, the variance blows up. So the variance blows up, the calculations go haphazard, a bunch of stuff happens there, right? So there are statistical ways of dealing with this. So this is not a data analysis problem, right? If somebody says that, hey, I'm a data analyst, I'm a decision scientist, I do metrics, right? The right data analyst, the right decision scientist will know a lot of statistical rigor to solve these problems. So there are, I mean, my way of judging a data scientist and data analysis is, have you heard about counterfactual evaluation or not? Right? In the industry, you will meet a lot of data scientists, a lot of data analysts. All they're doing is like SQL monkeys, right? I mean, not to degrade them, nothing like that. But then like somebody's just writing SQL queries and not having any understanding of the statistics behind any of this, right? Then you should be judging them, right? So essentially, this is where counterfactual evaluation comes in. I think like you mentioned about off-policy learning, right? Off-policy evaluation. I was surprised that, oh, we know we have somebody. So off-policy evaluation here says, my new recommendation policy is very different than the logging policy. So this is off-policy. The new model I want to evaluate is very, very different than the previous model which I had, right? The previous policy pi, I use that to log my data. Now this is very different than the new model, right? So then I have to do off-policy evaluation. So long story short, combining it all together, can I collect this data and do some maths so that I can evaluate off policies, right? New policy, which is very, very different than the previous recommendation strategies. If I can evaluate that, then we are really good. Now, this is what it took us 1.5 years at Spotify at the scale at which we were with the amount of talent we had. It took us a long time to get right. But then once we got right, it gave a huge pace improvement in our experimentation ability. So this is the state of the art, right? I mean, if you are in the industry, if you're touching upon counterfactual evaluations, if you go and talk an interview with a team, and if you ask like, okay, what's your evaluation, right? If the manager says that, hey, we do counterfactual evaluation, then you know that you are in the cream of the industry, right? Again, I'm not saying that others aren't there, but then like these are signals which I would use to like judge people. I do judge people a lot, as you can kind of conveniently see. So there's a lot of work which we have done as well along the times. So like off-policy evaluation, counterfactual evaluation, estimating biases, all of that is here, right? Again, Praveen is a great, very, very close friend. We have a paper together, actually. Again, I won't go to my profile and talk about it. But one of the examples, right? You go to google.com, you type in a query, the first result Google sends you, people are going to click on it, right? Because people think that, oh, Google is giving me that result. Then of course, like it will be good. People always will click on it. So there's a position bias there. The rank 11th post, right, which was not shown on the homepage, that may be a better post, but because of the position bias, it never gets clicked enough. And that's why like it suffers, right? So how do we incorporate that when I'm evaluating my models? Can I debias that? Can I debias that position bias, right? All of that goes into designing a better offline evaluation system. And this is not just SQL. I mean, this is very, very math heavy. Why am I saying it's math heavy when half an hour ago I was like, hey, people who are math heavy, they don't know how the product works, right? This is because I think I've seen generally, like in the industry, in the talent I talk with, they don't view evaluation as a first class problem, right? They view, oh, I'm going to evaluate, I'm not going to be the model ML person, right? I think the right leader would really identify that, hey, the evaluation people in my team are one of the strongest people I need. So recently, like at ShareChat, we've hired a bunch of very, very strong people who have statistical rigor. I mean, very good on statistics. So we've gone to like hedge funds, right? I mean, one of the highest paying people in the industry, hedge funds, all of them are brilliant on stats. Let's bring them. They haven't worked on recommendations at all, but then they're very good on statistics. So that's the kind of talent which we are looking out for to solve some of these problems. So again, I'm going to just like present in the last slide and then wrap up. What's going on, right? We talked about metrics, we talked about implicit, explicit, counterfactual evaluation slightly. I'll give you one brief example of the metrics which we look at. So short term, they could be item level metrics, they could be entire page level metrics, they could be session level metrics, and they could be intra-session metrics, right? So again, like I think there was a question earlier from Professor Anirban on short term, long term. So this is that spectrum, right? You start looking at just a point, you're looking at the entire whole page, you start looking at the session, you start looking at intersession, and all that. How like return rate. An example of session level feedback is like your dwell time, session length, right? Or the intra-session is like your average return rate. Are you returning back next week? Are you a D7 retention user and all? So these are some metrics which we start looking at. And these are some examples, right? I mean, like intra-session is dwell time, session length, revisit rate, bounce rate. Bounce rate is abandonment. So it could be that, hey, I don't like what I see on the homepage. I go to the explore tab on Instagram. I don't like what it is there, right? I immediately bounce off and go somewhere else. That means I immediately abandon. So those are the metrics which we look at for. So then you have CTR and all that. In intersessions, you have like time between sessions and number of active days, number of sessions and all that. So I think that you're going to cover some of these next week in some flavor. But I think like last point, right? I mean, from single to multiple metrics, I think like by now, this is when you see at my face, you should look at this figure, this should pop up. If not, I haven't solved this problem enough. You've seen this before, right? I mean, it's not about just one metric, one stakeholder metrics. It's about multiple stakeholders, multiple metrics. And in a world of trade-offs, how do we balance multiple goals? One of the biggest problems I'm facing since last year, I don't have a solution for right now. I don't have a principal solution for, is this problem. And I think if you work on it, right, I mean, reach out to me personally. I would love to collaborate with anybody on the earth to come back with good solutions here. Let's spend 2 minutes talking about that. As an engineer, how do I make rollout decisions? Right? Each change I make impacts all the other stakeholders and all the metrics. So what trade-offs are allowed? What trade-offs are preferred? How do we make that decision? And it's not a science problem, right? I mean, it is a science problem, but then as an engineer, I mean, I have to deploy stuff. I don't care about your fancy math, your fancy ML, right? I'm a normal software engineer. I have to make a change. I make a change, I get a trade-off. How do we deal with it? This is actually what is one of the core things which I worked on at Spotify. Very similar problems at ShareChat, very similar problems across the industry. I can promise you, if you develop good solutions for this, if you give a talk, people from Spotify, Netflix will pay to be an attendee in your talk. Why? Because this is a problem they're all dealing with. Here is an example. I have 5 objectives, right? I have user satisfaction, like short-term session length. I have long-term satisfaction, 7-day return rate. Like, are you coming back more to my platform? I have supplier metric. This could be a proxy for revenue, let's say, that are you earning more money or not? Then there is a creator middle class. I care about my creators. Something, okay, good. I care about my creators. And am I beefing up the middle class or the head of the creator as well? And then there's user-creator relationship. So as a product, I care about all these 5 metrics. If you look at the green row, ranker 5 is giving me a 15% gain in revenue. I'm assuming the supply metric is revenue metric, right? So this green row is giving me a 15% gain in revenue and a 4% gain in 7-day return rate, which is great, right? I mean, win-win, great. But you know what? The ranker 3, the blue guy here, is giving me 24% gain in revenue and neutral on return rate. Now, how do I make a ship decision here? What should I ship? right? I mean, I have these 5 rankers, right? They're all performing better in one way or the other. What model should I roll out to 100%? What do I ship? Right. Depends where your priority is, right? Any other answer? Sorry. Yeah, what's your main objective? Great. Any other thoughts? You look like you were about to say something. Yeah. Right. Balance a mixture of all these problems. Yes. Any other thoughts? Right. So basically an ensemble policy, right, which gives you, but then even when you do that, right, you're going to come back with something like this. It's going to do well on one objective, do not well on the other objective, and you're going to have a trade-off here. Weighted sum is your answer, right? Yes. So you start seeing that, at least you're acknowledging the problem, right? The question is, I mean, how do I understand whether a 2% change in objective 1 is equivalent to a 3% change in objective 2 is equivalent to a 5% change in objective 3? What's the common currency here? How do I trade these off? I mean, these are all different numbers, different values. How do I make that conversion, right? And it's a nightmare of a problem. People in finance, right? I mean, the closest example I have is nobody converts pairwise currencies. They all convert to US dollar. US dollar was pegged to gold, at least until 1971. So then you have a common currency there. What is the common currency here? We don't have a common currency. Maybe LTV, like lifetime value, long-term value, something like that, right? Maybe I need a common currency wherein I can convert all of these objectives into the common currency and do that exchange rates there. Now, people in finance solve some exchange rate problem in the automated market making. Like, I don't know if you're familiar with hedge funds or any of the blockchain crypto work, like a lot of very like Uniswap, anybody in the crypto world? Any crypto fanatics here? So again, like if not, right? I mean, look, I can promise you, if not machine learning, I would be in the blockchain world right now. If you're not aware of it, then like some red flag, I mean, I'm sorry, you guys are still new, second, third year undergrad, way too early for you to do that. But yeah, blockchain is also pro blockchain, yay, go blockchain and all that. But essentially, right, in the finance world, people do price matching, right? I mean, Robinhood and all these like exchange rates, exchange platforms, right? They see that, okay, some user is willing to trade this stock for $70, somebody is willing to buy it for 69, I can't match it. But the moment I find somebody willing to trade at 64.5 and there is somebody willing to buy at 64.5, suddenly I have that matching, right? So there are automated mechanisms of AMMs, automated market matching, wherein they do price discovery. Price discovery means that they find out the exchange rate. So maybe something is there. Maybe I need a common currency. Maybe I need to understand that exchange rate better and then come back with this. It's very rare, once in a year event, when you see a lot of positives. Most of the times there are some positives, some negatives, right? Once a year, you get an A/B test at a company as big as Spotify, which you get all positives, and the people who are behind it, they get promoted. A lot of good things happen and all that. But then it's very rare. But when it does happen, you have to deal with this exchange rate problem. So that's the governance problem. The moment you specify how you deal with it, then you are stamping your authority on the platform, that this is what the platform stands for. What happens is most people don't ever do that. They just go for clicks. Clicks go to clickbaits. Clickbaits go to polarization of content, and bad things happen on the society level, right? So I think, like, again, I'm trivializing a lot of things, but then at least my pitch is that all these platform designers, they should be explicit about the trade-offs and encode that governance, right? This is what I meant. What trade-offs are allowed, what trade-offs are preferred. Develop the spine, develop the backbone to make a case about this in your platforms and then enact that. So we had one thing to mention, like we had a paper at Nurus workshop. It's under review right now at a conference. Nobody here should, I mean, some people might be reviewing, but at least in this paper, we were trying to understand, like in a multi-objective world, when something goes bad, right? Who should I blame? I showed you this ranking. Half of it was user-driven, half of it was creator-driven, half of it was ads or revenue-driven. Now you abandoned the session, you hated it. Now who should I go back and blame this to? So there's like causal disentangling. That can I disentangle the impact of multiple intervention? Multiple intervention is like multiple objectives making that decision. And when shit hits the ceiling, who should I blame? And who do I go back and correct for? So there's a lot of like, this is a very, very, very maths heavy, one of the most maths heavy papers, because this involves do calculus. Do calculus is a way to do causal analysis. Julia Pearl, he's one of the founding people of graphical models. He invented a new calculus, new literal calculus to make this pre-intervention, post-intervention causal modeling. Again, like if you hear do calculus anytime, causal inference anytime, that's again state of the art-ish on the evaluation front. Just to make the point on counterfactual evaluation, right? I mean, what would happen if Mahatma Gandhi wasn't assassinated in India? So what would the state of the country be? Do we know that? No, we don't know that. Why? Because we never observed that, right? So how do we make an inference about a situation we never observed? That's the counterfactual, right? It's not factual, it's counterfactual. Something never happened, but then can I reason about that? Traditional machine learning, graphical models, they cannot reason about that. Why? Because I don't have that data. Most traditional machine learning works on observed data. A world in India without Gandhi getting assassinated, without Hitler getting assassinated, that doesn't exist, right? So I cannot infer about that. So there is a mechanism in the maths community which is looking at these do calculus, which can give you some guaranteed in inferences. Again, the point is not to scare you. The point is that, hey, this is also pretty, very neat. And I think like Lyft, Spotify, they are starting to use some of them in the industry. This is one of the most fascinating. I mean, for people who know what I'm talking about, I think this is one of the coolest. This is like the Iron Man for us in the field, right? That, hey, some team is using that, then I think like this is something very, very cool to show off. Problem is like 95% of the people won't know what we're talking about. But at least there's a lot of like good stuff here. So that's it. I mean, like I think like we have a dedicated focus on ML lab across different companies doing evaluation at scale. So that's it. We made it. I'm gonna summarize in the next 1 minute, and then we can go home or go to the party, which we have at the guest house. But yeah, I think it's important to think about evaluation. Evaluation often gets underlooked. People go very pro ML. They're like monkeys throwing darts in the air. Let's throw an ML model, it will work. No, that's not how it works. We should pay more attention to evaluation, problem understanding, different aspects of evaluation. The one key thing I want you to take away is the offline-online correlation problem. And if you're in the interviewing at any other company, and then you mention this, right? If the interviewer doesn't know it, then I think you should just kind of auto-reject, I mean, again, blatant statements. But make sure that you know how to judge companies, because look, your career is in your hands, right? So make very optimal decisions. My job here is to just to equip you with, hey, what's the state of the art in the industry so that you can understand better. And finally, off-policy evaluation, counterfactual evaluation is one of the state-of-the-art things. If you go on to do a PhD, causal inference, counterfactual evaluation, amazing problems. Everybody in the industry will end up hiring these people, and there's a huge shortage of talent in this space. So again, great topics to dive into. I'm not going to talk about deployment. I mean, that's too much. Cool. We're going to wrap it up. So this is me for the last time summarizing. We've talked about introduction. I've said a lot about the importance of recommendations. We talked about multi-stage recommendations. Started with candidate generator, ranking, evaluation. We talked about ML approaches, multitask models, simple two-tower models, contextual bandit models. We replaced the bandits by a multi-objective. I mean, we did cover a lot of this stuff. I mean, your recall for each of these topics may be close to 0 by now, but at least we touched upon few major approaches. We started looking at user interactions, right? I mean, user representations, but more importantly, like, can I develop these satellite ML models for the user, start using them? And then we started looking at evaluation, right? The thing I want to close with are two things. One is actually three things. One is this view, right? At least after today, when you think about recommendations, it's not just a matrix factorization world. It's a very, very nuanced world, to the extent that I would go on record and say that, look, recommender systems to me, arguably, are one of the most complex ML models in deployment in the world right now. And they have a huge ask, not only from the modeling side, but also on the infrastructure side, because of the scale and complexity and the real-time latency requirements, right? The engineering asks are also very, very hard. So I think, like, I mean, not because I'm working on recommendations, you should pay more respect to these people, but then generally, right? I mean, I never did recommendations before 2017. I had a search machine learning background. But then this is a nuanced view of recommender systems. This is a nuanced view of how I think companies should think about this. So maybe in 5 years down the line, if you see very few companies, like handful, maybe 1 or 2, have their systems designed in this way. So 5 years from now, if you remember this, if you see that most of these companies are following this, then you know that Rishabh did a good job at explaining and circulating this. Because again, at least my research focus has been this topic, and I'm gonna die trying, unless I get evidence that, hey, it doesn't work. That's the goal which I personally would have. And finally, this is a summary of everything I want to pursue and mention, right? Look, it's an ecosystem we are designing. It's not a simple model. It's not a single model which you are designing, which you're optimizing for. You got to make sure that you understand the user, you understand the supplier, you understand the platform, you do this balancing, you have this feedback loops, you have the decisioning process, you have the measurement loop, and then you show that to the user, and then you evaluate, right? So I think like it's very important to make sure that we are paying enough attention to the ecosystem problem here. It's not a single model with a single evaluation. It's an entire ecosystem which we are supposed to design for each of these problems, right? So again, I mean, I think this slide is the end all be all of this talk. And that's it from my side. Thank you so much for staying back and listening. I think like we have close to, I'm going to take a pic from here if you don't mind. I think we're close to 95% retention. My product may not have a 90% retention on ShareChat, but this at least this course has a decent retention. So thanks for staying back.